Okay, we're on section 6.4, part B with the half angle identities. And by using the power reduction identities, if we square root both sides and then substitute u as 2 alpha, and then solve this for alpha, u would be over 2. So we can make these substitutions and get a result of the half angle identities. So we have one of them for cosine of half angle, one of them for sine of half angle, and then we have 3 of them that could be used for tangent. So looking at these examples, if we're doing sine of 105, we don't have a nice neat answer for 105, so we can change this to being 210 divided by 2 is the same as 105. So we do have a half angle formula for sine. We can plug in with plus or minus the square root of, right up here, 1 minus cosine of our angle, which is this 210 degrees, all divided by 2. Now remember, cosine of 210, it has a reference angle of 30 degrees, and it's in the second quadrant, or third quadrant, which means cosine is negative. So this is the same as the negative of a 30-degree angle. Cosine is in the second quadrant here of 105 is positive. So this now is positive. And then cosine of 30 degrees is square root of 3 over 2, but it's negative. So we now have minus a negative, which is positive, square root of 3 over 2, all divided by 2. So now we just have to simplify this. If you add the numerators together, you get 2 over 2 plus square root of 3 over 2, which is like 2 plus square root of 3 all over 2. And the denominator now is 2. And remember, multiplying by 1/2 is the same as dividing by 2. So that 1/2 is now multiplied to that. And you get the square root of, you can distribute this in, we have now the denominator is multiplied by 2, which puts it over 4. And since this is a perfect square root, the denominator now does not have to be rationalized, it just needs to be simplified down to just be square root of 4 is 2. Looking at the second one, we have sine is given to us as negative 3/5, and it's in quadrant 4, and we want the half angle formula for tangent. So tangent, we have 3 ways that we could solve this. So let's just pick one. I'll start with this one on the bottom. We're going to do tangent of theta over 2 is the same as sine of theta over 1 plus cosine of theta. Well, sine of theta was given to us as negative 3/5. Cosine in the fourth quadrant is positive. And then cosine using our perfect Pythagorean triple of a 3, 4, 5. If 3 is opposite, 4 is adjacent, and the hypotenuse is still 5. So we just have to simplify that. We have negative 3/5 in the numerator. 5/5 plus 4/5 is 9/5. When you flip and multiply, the 5's cancel. You're left with negative 3/9, which reduces to negative 1/3, which also makes sense for a fourth quadrant angle is going to be negative for tangent. That's using the last formula. If we use maybe another formula, let's say we use this second formula, we can still do the process of our half angle formula of plugging and chugging with 1 minus cosine of alpha over sine of alpha, or theta. So if we look at 1 minus cosine, it's just the same as the last time, is 4/5. Sine was given to us as negative 3/5. So looking at the numerator, 5/5 minus 4/5 is 1/5. Denominator is negative 3/5. If we flip and multiply, that simplifies to the same, negative 1/3. If we do this one more time with the last formula up here, we can still get the same result. If we're doing our half angle formula, we can do that to positive or negative of the square root of 1 minus cosine of alpha or theta over 1 plus cosine of theta. Realizing this is in quadrant 4, we know tangent is going to be negative in the fourth quadrant, so that takes care of putting this into the negative. It's a square root of 1 minus cosine of alpha, or cosine of theta we already figured out was 4/5. And we put 1 plus 4/5 in the denominator. Now we can simplify this. We have negative of the square root of 5/5 minus 4/5 is 1/5. 5/5 plus 4/5 is 9/5. If you flip and multiply, the 5's cancel. You're left with negative square root of 1/9. And then the square root of 1/9 is again 1/3, same as the answer that we got on the other 2 tries.